Welcome to Lesson 6 of Module 5 on Extended Query Formulation with SQL. I'm going to start with two important questions about query formulation errors. What query formulation error can lead to a loss of a job? What is the most difficult error to detect? In many years of teaching query formulation, I have found that correct examples and guidelines are not sufficient. Learners also need awareness of incorrect examples with various kinds of errors. Awareness of query formulation errors can help avoid errors as well as diagnose incorrect statements, reducing frustration and increasing confidence. Since even skilled professionals make errors, you should remain vigilant about query formulation errors as your skills progress. The primary objective of this lesson is to avoid query formulation errors. Secondary objectives are to detect and correct your inevitable errors as well as errors made by others. In addition to avoiding errors, you should write statements with good coding styles so that others can easily understand your statements. Syntax errors are easy to detect because the SQL compiler generates an error message. Because a statement does not execute, syntax errors are the most severe. Redundancy and semantic errors are subtle because the SQL compiler does not indicate an error. Errors of redundancy have least severity as the result contains correct rows, but extra resource consumption occurs. Semantic errors are more severe as the result contains incorrect rows, either too many rows or missing rows. Semantic errors can sometimes cause excessive resource consumption. Although syntax errors are easy to detect, correcting a syntax error can be difficult, especially if a statement contains multiple syntax errors. SQL compilers have wide variation on quality of error messages. A common syntax error involves a misspelled keyword. More subtle errors are a missing table name and an unqualified column name. Two common redundancy errors are an extra table and an unneeded group by clause. With these errors, statements still produce correct rows, although extra resource consumption occurs. Semantic errors are the most serious because a statement generates incorrect rows, either too many rows or too few rows. A missing join condition is the most serious error because a statement generates excessive rows and lots of extra resource consumption may occur. A more subtle semantic error involves missing parentheses. Example 1 lists the student name and offer number in which the student earned a grade greater than 3.7 and took the offering in fall 2016. The statement contains a missing join condition, an example of a semantic error. The missing join condition generates extra enrollment rows that do not match offering rows because of the missing join condition. You should remember that joining three tables typically requires two join conditions. Now let's execute example 1 in the Oracle SQL Developer to detect extra rows in the result. The statement with the missing join condition generates 10 rows, mostly extra rows. Correcting the statement by adding the missing join condition, enrollment.offernumber equal offering.offernumber, generates the correct result containing only a single row. Example 2 involves the same problem statement as example 1. The SQL statement contains a redundancy error, not a semantic error. The statement contains a redundancy error due to the unnecessary group by clause. Since the problem definition does not involve summary calculations in the result or conditions, the statement should not have a group by clause. Now, let's execute example 2 in the Oracle SQL Developer. Due to the small size of the tables, you cannot detect extra resource consumption. On large tables, you should be able to detect extra resource consumption. The corrected statement, without the group by clause, contains the same row in the result. Example 3 lists the offer number, course number, and faculty number for course offerings scheduled in spring or summer of 2016. The statement contains a semantic error due to missing parentheses. The statement requires parentheses to ensure that the two conditions on off term are evaluated together. Without the parentheses, the AND operator takes precedence over the OR operator. The where clause first evaluates off term equals summer and off year equals 2016, followed by the condition off term equals spring, connected by the OR operator. You can correct the statement either by adding parentheses around the first two conditions as shown in the second statement, or by using the IN operator as shown in the third statement. Now let's execute example 3 in the Oracle SQL Developer. Note that the statement produces rows in spring 2017. The correct statements only show one row in the result in summer 2016. Beyond awareness of errors, you should strive to write statements with good coding practices. The examples in other lessons of Module 5 demonstrate good coding practices. This slide summarizes prominent types of poor SQL coding practices. Some of the practices are subjective, such as clause alignment, with multiple ways to achieve good practice. You should avoid most practices, such as incompatible constants and inappropriate usage of the like operator. Example 4 demonstrates poor coding practices in a statement to list Bob Norbert's course schedule in spring 2017. The statement contains poor clause alignment, an incompatible constant, and a like operator without a pattern matching character. As an exercise, you should reformat the statement and change the poor coding practices. You can find a revised statement in a Module 5 document. Let's wrap up Lesson 6 about query formulation errors. To avoid errors, you should be aware of the types of errors and examples of errors. Minimizing errors will reduce frustration with query formulation. Syntax errors are generally easy to detect, but sometimes difficult to fix, especially with multiple syntax errors in the same statement. Redundancy errors generate correct rows in the result, but cause excessive resource consumption. Semantic errors generate incorrect rows in the result and sometimes cause excessive resource consumption. Good coding practices ensure that coworkers will be able to read your statements. This lesson concludes Module 5. You can find additional examples of query formulation errors in the documents for Module 5. In answer to the opening questions, a missing join condition is the most serious error for the subset of the select statement used in this course. On large tables, a missing join condition will cause many extra rows with very excessive resource consumption. The extra resource consumption could be enough to cause a poor work evaluation or even loss of a job. The most subtle type of error to detect is a semantic error that generates anticipated rows in the result. However, after addition of new rows, execution of the same statement generates extra rows in the result. In example 3 of this lesson, execution of the statement generates correct rows if the offering table only contained rows in spring semester of 2016. However, after adding rows in spring 2017, execution of the same statement generates these new rows in the result. The spring 2017 rows are not in the result of the corrected statement with proper placement of parentheses.